Hello and welcome back to another session on Artificial Intelligence for Beginners. Now, as you already know, we are in the seventh session of this really short course on, or more of a primer on artificial intelligence, and today we are going to talk about the concepts related to artificial intelligence. So, to begin with, I want to give you a very simple classification of AI or artificial intelligence. And we have already spoken about this in some of our previous lessons, but I just wanted to make sure that it's crystal clear to you that what are the different ways in which we can classify artificial intelligence. So on your screen, as you can see, there are multiple ways to classify AI. It can be based on their structure, it can be based on the technology, it can be based on their functionalities, and so much more. So to begin with, let's talk about classification, which is most commonly used. And we talk about AI in three different ways, which is a weak or a narrow AI, a general AI, or a subconscious AI. So what do we exactly mean by that? We'll just get to that, but before that, it's really important to understand that artificial intelligence is booming right now, and its applications from all the way to natural language processing, which are being also used in chatbots. Similarly, it's used in data science, it's used in predictive analytics, machine learning, and so much more is just expanding. And that is why we truly need to understand that how AI is actually classified. So I'm just going to come back to the classification in just a moment. But before that, we need to understand what are the basic differences between AI and human decision making, right? And you might be thinking that, oh, we are already in like the last stages of this course. Why are we still talking about all this? Because it's really important for you to understand the basic concepts. That's the whole purpose of this entire course, and that is also one of the reasons that this video is a bit longer than the other videos, because I have at least 2 or 3 concepts to cover here, and I would really like you to bear with me. So how do humans decide, right? So as humans, we observe any we observe any visible phenomenon and bodies of evidence. So for example, this cute little dog, we know it's a dog, right? And why is that? Because we have been trained in such a way when we were young, when we were kids. The moment we see this image, we are able to generate a hypothesis or multiple hypotheses, and we can interpret what we are seeing. Based on this, we can decide whether our hypothesis is right or wrong. So, for example, if someone said this is a cat, then they would be wrong. But what if it actually was a cat? In that case, you're right. So, visual interpretation is really important for humans to understand what they are seeing and whether they're right or wrong. So, we always choose the option which seems best, and this best option is based on our own rationality and the knowledge which we have attained over the years. So, based on that, we act accordingly, right? Now, this is the entire process of how humans decide very basic things. And because we have been evolved to such a large extent, these kind of things seem pretty ordained to us, right? We believe that it's pretty easy to understand these things, not for a machine. And things are very different for a machine. So once again, I just want to reiterate that what exactly artificial intelligence is. So on your screen, you can see AI is that branch of computer science which deals with trying to simulate human intelligence into a machine, right? We are just trying to replicate whatever we do as humans mentally and put it in a machine. That's the whole essence of AI. But why is it so difficult? We have been on it for the last 50, 60 years, and where have we reached right now? So this is more of an ideal situation for an AI system. As humans, we all have high expectations out of everything, not just each other, but the same goes with artificial intelligence. So we want our machines to be able to learn. We want our machines to be able to reason, to gain knowledge, perceive things, manipulate things, have social intelligence, and etc. etc. But in the current stage, if you remember in the beginning of the video, I told you we can classify AI in 3 different ways, which is weak, general, and super. So, what exactly is a weak AI? And why would any form of artificial intelligence be called weak. So there's a reason for that, and let me give you a very simple example. I'm sure most of you have heard about Siri or Alexa or Google Assistant or any of these smart devices might be present right now in your home. So these are actually a form of weak AI, or we can also call them artificial narrow intelligence. But why? Why are they weak? Do they have to lift things? Well, literally they cannot, right? And it's as simple as that. So can you ask one of these smart devices to go pick up the milk for you? Can you ask them to grab you some food? Can you ask them to accompany you on a trip? Until and unless you pick them up and put them in your back seat or your side seat of your car, it's not possible. So basically their functionalities are limited, right? Even though they are able to perform a number of functions based on your input and based on what they have been taught, they still have a lot of limitations, not only in the term of physical, but also in terms of virtual. So basically they are not able to think, right? They're not able to process a lot of things until and unless they receive an input from the user. And that is exactly why most of the applications of artificial intelligence in the market right now are categorized as weak AI, because they are limited to a large extent in the functionalities of what they can perform, and the moment you put them out of their comfort zone, they don't work. Okay, so moving on, we come to general AI, also referred to as strong AI or deep AI. And yeah, I think it should be able to at least arm wrestle with humans. But jokes aside, a strong AI should have the ability to mimic human behavior and apply its intelligence to solve problems. Not just that, the most crucial aspect of a general AI is that it should have the ability to discern the needs of a person, the emotions, the beliefs, and the thought process. And this is actually has been, you can say, the Achilles heel of artificial intelligence, that scientists have not been able to build systems which have emotions, right? We have tried hard. We have actually provided a lot of data for this, and some people might say that, what are you talking about? We have sentiment analysis, we have emotional AI. I know it's all out there, but the intrinsic ability of a machine to actually have emotions, to cry, to feel bad, to feel pain, right? These still have not been able to evolve. Not just today. I mean, if you've seen that movie I Robot by Will Smith, I think that was set somewhere in the year 2050 or 2060. Robots are not able to do that even at that time. Well, anyways, but this has been the largest, the biggest limitation for artificial intelligence, and general AI is still not practical, so as to say, and yeah, it's also called as artificial general intelligence. Moving on to the third point, or the third form of AI, which is super or subconscious AI. Now, once again, I think we are moving into the Matrix zone, right? I'm sure a lot of you have seen the movie Matrix, and this is the point where the machine actually becomes self aware and surpasses the capacity of human intelligence, and it would theoretically be better at everything than us. So, not just at playing chess, not just at playing the game Go, not just flying airplanes on autopilot mode, but overall. So, as humans, we have tremendous capabilities. A person who's good at studies can also be good at tennis. He or she can also be good at maths. They can also be good at economics, stockbroking, adventure sports, so on and so forth. And these are a very diverse set of activities, but we as humans are able to somehow excel at most of them. So when an artificial intelligence system is able to surpass us in all these things, then we would reach a stage of super or subconscious AI. Once again, it's still a distant dream right now. Obviously, a lot of people around the world are working really hard to achieve something like this, but I don't see it happening at least for the next 40 to 50 years. Yeah, call me pessimistic on this one, but I think that's what my honest opinion about this is. Okay, at this point, I just want to apologize to you all once again for extending the length of this video a bit too much compared to the others, but just bear with me, and we have a few more concepts to cover before we move on. So we can also classify AI based on functionalities. I don't want to get into the details of this. That's why I've put a link in the video. I'm going to put this same link in the description below. You can always visit this site and find out more about categorizing AI based on functionalities. So let's move on to another interesting subfield of AI, which is deep learning. Now, what happens is that many people confuse deep learning, deep mining, machine learning, and AI. So deep learning is not exactly a subset of AI, but it's actually a subset of machine learning. And what does it do? It actually simulates human decision making from use of neural networks. What are neural networks? Once again, we are not going to get into the details of this because then we would have to go back to biology from high school. But just in essence, neural networks are something which allow us for stages of decision making. Not clear? Let me give you a very simple example. If someone asks us to jump from a cliff, would you do that? Probably not, right? I mean, why would you just jump down from a cliff just because someone asked you to? But if you, so let me just skip on to the next slide, and I think it'll be much easier for you to understand. So whenever someone asks us to do something as innate or as simple as jumping down from a cliff, so that's the input, right? The person is asking us to do something, and if there was no processing between our input and our output, then we would simply jump down the cliff. But what happens is that you receive the input, you think about it, you process it, you think about the pros and cons of the decision, that you might break a few bones, you could actually die, what will happen to you, do you really want to do that, does it benefit you in some way, etc., etc. So all this decision making is done with the help of neural networks. Now, of course, biology students and doctors might hate me right now because I'm oversimplifying the concept, but in essence, that's what it means. So deep learning picks up this exact phenomenon and tries to replicate by using artificial neural networks. So once again, what happens is the moment an input is provided to the machine, it does not take an immediate decision on it. So it sits down on it, it has a few layers which are actually called the artificial neural networks. It allows the system to churn all this data, think about the pros and cons of the decision, and eventually provides an output. Okay, so this field of data science, now actually this is one of the subsets of data science under the aegis of machine learning. So this entire concept is known as deep learning, and it's primarily ridden with the concept of artificial neural networks. Now once again, my objective here is not to teach you in detail about deep learning. I would love to do that in the future. If you're interested, you can always mention it in the comments if you want more clarity on it, or if you want another course on this topic. I would love to bring out one. But for the time being, let's move on to the next topic, which is data mining. Now, once again, data mining, as the name suggests, very simple. It aims to find previously unknown relationships, patterns, and regularities in a large data set. As you can see in this picture, mining is very similar, right? We don't know what we're going to find in mining. You might be mining for gold, you might find oil, you might be mining for oil, you might find minerals. There's a possibility you might not find anything, or you might find something which you are not looking for, or etc., etc. And that is why we call this data mining, because it never begins with a specific hypothesis, and it's very similar to machine learning. Why is it similar to machine learning? Because both of these fields are concerned with analyzing data and extracting insights, but there are certain differences. So machine learning is limited. It's quite limited in its capabilities, that it tries to improve the experience of a given task. But when we talk about data mining, it actually analyzes the data to view previously unseen patterns. So machine learning actually works on a known knowledge, but deep mining is very exploratory in nature and always searching for new patterns. Now, once again, to give you an example, I'm gonna really oversimplify things here, and this time let's piss off the astronomers, right? So we know about our solar system, right? We know how many planets are there. We know about the asteroids, etc. But if we had a bird's eye view of the solar system, and this just go back a few years and imagine that we don't know about the planets. What would happen that if we only had a very limited view of the solar system? So suppose we are looking through a keyhole, right? And that's our telescope. And we are only looking at the solar system in bits and pieces. And we take thousands of images of the solar system and then we bring them together. But for some reason, for example, the images are really complex for us to understand, and we are not just being able to collate the puzzle together into a picture of the solar system. So we train a machine to do that, and we literally just provide the machine with these pictures and ask it to do something about it. Now if your algorithm is right, if the training is right, then the machine will be able to find patterns which even humans were not able to see. And when it's actually able to find patterns which even we were not looking for, then we are actually moving into the domain of data mining. As I said, I have once again oversimplified things by telling you this, but that's the essence of data mining. And just bear with me for another minute or so, and we are almost done with this lesson. The last concept is machine learning. Once again, as I told you, machine learning is now a subset of artificial intelligence, and it deals with computer algorithms which are used for analyzing the data. What does it mean? Basically, every machine needs to be taught, right? If you remember the beginning of the lesson, I told you how humans make decisions. We see a dog, we know it's a dog. We see a cat, we know it's a cat. Things are not so simple for machines, and the machines actually has to use a lot of data to make intelligent decisions, and it cannot be trained repeatedly, right? You've trained a machine once, you showed it thousands of pictures of a dog, you would expect the machine to then recognize a dog every time it sees it, because you can't expect to carry that data around with you, and every time you have to train a machine what a dog is, you keep feeding the data into it, because that would just make things more complicated, and that's not the reason why AI is in existence. So the entire role of machine learning is to train the machine to help solve problems which humans take more time to do, and basically improvise whenever required and make the entire process more efficient. So what we're going to do in our next and the last video of this really short course on AI is that I'm going to show you a real life example of machine learning. I'm going to show you how exactly you can use machine learning to determine some aspects. It's a very simple case study where a person is trying to decide when to order a pizza in a week and how long is the pizza going to take to come to their home. It's really interesting. I would like you to join me in that lesson, and we will actually try to cover the very basics of machine learning through that example. And obviously the last point here is that machine learning requires large data sets. I think I have spoken about this at length in all my videos, and now it's crystal clear to you as well. Well, that's all for this lesson. I hope you enjoyed this bit extended video, but I truly want to see you in the next and the last video for this course. Thanks for watching once again. Have a wonderful day. Thank you.